You've probably heard people say it a million times, right? They're relying on muscle memory to shoot a basketball, play a guitar riff, or even just type on a keyboard. It's the go-to phrase for any skill that feels totally automatic. But what if I told you that the entire idea of muscles remembering anything is, well, a myth? Let's get into what's really happening. So, let's start there. What do we even mean when we say muscle memory? Yeah, when we talk about it, we're thinking our muscles have these little memory banks, right? It's the reason you cannot ride a bike for 10 years, hop on, and just go. It feels like the muscles themselves just remember how. At least that's the story we've always told ourselves. But here's the twist. That's not really how it works. The actual truth is, your muscles have zero capacity for memory. They're amazing at producing force, they're the engines, but the intelligence, the skill, the actual memory, that all lives somewhere else entirely. So if it's not in your biceps or your quads, where is it? Well, the real command center for every skilled movement you've ever learned is a super complex, incredibly organized network inside your brain. That's where the master plan is created, stored, and constantly being updated. And right at the heart of this whole operation, you've got three main players. Think of them as the C-suite, the top executives running the show: the cerebral cortex, the basal ganglia, and the cerebellum. They're all in constant communication, orchestrating every single move you make. So let's break down what each one does. Okay, first up, the cerebral cortex. This is the big boss, the architect of the whole plan. It's the part of your brain that says, hey, I want to pick up that cup of coffee. It comes up with the initial idea and draws up the blueprint for that voluntary movement. So once that plan is made, it gets sent over to the basal ganglia. Now this guy is the gatekeeper. Its job is absolutely critical. It looks at all the possible plans and has to pick the one best action for right now, while telling all the other competing ideas to just stand down. And finally, there's the cerebellum. You can think of this one as the refiner. While the movement is actually happening, the cerebellum is constantly comparing the intended plan with what your body is actually doing. It's making these tiny, on-the-fly adjustments to correct errors and make sure everything is smooth, coordinated, and hits the mark. All right, so we've met the team, the architect, the gatekeeper, and the refiner. But I want to zoom in on that gatekeeper, the basal ganglia, for a second, because the way it makes decisions in a split second is just incredible. See, the basal ganglia uses this brilliant system of go and no-go pathways. You can literally think of it like a traffic light for your body's intentions. The go pathway gives the green light to the one specific movement you want to make, while the no-go pathway simultaneously slams on the brakes for everything else, hitting them all with a red light. This whole go/no-go system is why you can instantly, without even thinking, decide to swing the bat instead of adjusting your helmet, or hit one key on a piano instead of the one right next to it. It's a lightning-fast selection process that prevents total motor chaos. Okay, so the brain has a plan, it's picked the right one, and it's ready to fine-tune it. But how does that thought, that electrical signal in your head, actually make your bicep contract? How does it become real physical force? That's the final piece of the puzzle. Well, the answer comes down to something called a motor unit. This is the final messenger, the crucial link between your nervous system and your muscles. It's basically one single nerve cell, a motor neuron, and the group of muscle fibers it's connected to. When that neuron fires, every single muscle fiber it's attached to contracts, period. So how does the brain control exactly how much force to use? Not too much, not too little? Well, it's got two main tricks up its sleeve. First, recruitment. For a light touch, it just activates a few small motor units. But to lift something heavy, it starts recruiting more and more of the big, powerful units. And second, there's rate coding. It can simply tell the active units to fire faster and faster to generate more force. It's how you get that incredibly fine-tuned control. And get this, the speed of that rate coding is just mind-blowing. For really explosive movements like a sprinter bursting out of the blocks or a boxer throwing a punch, those motor neurons can fire over 100 times every single second. That is just unbelievably fast, and it's how your nervous system gets maximum power right when you need it. Okay, so let's bring this all back around. If the memory isn't in the muscle, and this whole complex system is running the show in your brain, well, that completely flips the script on what it means to practice, doesn't it? This is the single most important takeaway of this whole thing.
Every single time you practice, you are not training your muscles to remember. You are training your brain to be a better, smarter, and faster commander. Skill acquisition is a neurological upgrade, not just a muscular one.
So what's actually getting better? Well, practice makes your cortex, the architect, better at creating more efficient motor plans. It trains your basal ganglia, the gatekeeper, to select the right go pathway way more quickly. And it sharpens your cerebellum, the refiner, so it can predict and fix errors before they even happen. This whole process is what's called implicit learning. It's how we get so good at things that they become second nature, stuff we can't even explain how we do. And as the research makes really clear, these motor programs in our brain are never really finished. They are in a constant state of being tweaked and refined through learning. Every single repetition is a new piece of data for your brain to use. So, the next time you hear someone say muscle memory, you'll know the truth. The memory isn't in the muscle, it's in the master plan, that intricate, adaptable, and incredibly fast software running in your brain. Every swing, every note, every step is a testament to your brain's amazing ability to learn. And that brings us to our final thought. Knowing that every practice session is literally rewiring your brain, how will you approach it differently?